This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 5, Spur Gears, Forces, and Tooth Bending. Lesson 4 gave us the geometry, pitch, the pressure angle, the line of action. Now we put a load on the teeth. 3 ideas carry this lesson. The tangential tooth load comes from power, not from the resultant. The pressure angle splits off a radial force that pushes the gears apart and lands on the shaft bearings. And the tooth bends like a tiny cantilever. So the Lewis equation sizes the stress. Let's build them. Concept 1. The tooth as a loaded cantilever. The mating tooth pushes with one resultant force, W, aimed along the line of action, tilted at the pressure angle. Split it at the pitch point. The tangential piece is the transmitted load. It carries the power and bends the tooth. The radial piece points in toward the gear center. It drives the gears apart and shows up on the shaft bearings we sized in Lesson 2. Notice the pressure angle sits between the resultant and the tangential force, and at the tip, the tangential load bends the tooth like a short cantilever fixed at the root fillet, which is exactly where the stress peaks. Concept 2. The load comes from power, then the angle splits it. You never read the tangential load off the resultant. It is set by power crossing the mesh at the pitch line velocity. Pitch line velocity is pi times diameter times speed over 12, and the diameter is in inches, which is the classic trap. The transmitted load is 33,000 times horsepower over that velocity, the very same linear power relation from Lesson 1, with the tangential tooth load playing the role of force. Once you have the tangential load, the radial force is just it times the tangent of the pressure angle, and the resultant is it over the cosine. Same power that set shaft torque in Lesson 1 now shows up as a tooth load. Concept 3. The Lewis bending stress. Treat the tooth as a cantilever of face width F loaded at its tip, and the peak stress at the root is the Lewis equation. Transmitted load times diametral pitch over face width times the Lewis form factor. The form factor is 2 times x times diametral pitch over 3, where x comes from the tooth layout figure. On the exam, the form factor is given or you read it off that relation, and it is dimensionless. This is the same diametral pitch from Lesson 4. The handbook just writes it with a capital P here. The key intuition: diametral pitch is in the numerator, so at the same load, finer teeth are shorter and stubbier and actually carry more bending stress. Setup. Take the pinion from Lesson 4. 20 teeth, diametral pitch 5, so a 4-inch pitch diameter. It turns at 1200 and transmits 20 horsepower through a 20-degree full-depth tooth. Face width 1.5, Lewis form factor 0.32. We want the tangential, radial, and resultant tooth loads, then the root bending stress. Plan: velocity first, then the tangential load from power, then split it by the pressure angle. Solve. Part 1. Pitch line velocity is pi times diameter times speed over 12, with the diameter in inches, about 1257. The transmitted load is 33,000 times horsepower over that velocity, about 525. The SI formula gives the same load in kilonewtons as a crosscheck. Power in, tangential load out. Solve. Part 2. The radial load is the tangential times the tangent of the pressure angle, about 191, and that is the separating force that lands on the bearings from Lesson 2. The resultant on the line of action is the tangential over the cosine, about 559. And the Lewis stress uses only the tangential load, transmitted load times diametral pitch, over face width times form factor, about 5400. Note, the resultant never enters the stress. Traps. 5 ways this bits. 1. Pitch line velocity needs the diameter in inches with the over 12. Get that wrong, and every load is off by a factor of 12. 2. The tangential load comes from power. Never plug the resultant into the stress. 3. Diametral pitch is in the numerator of the stress, so finer teeth carry more bending, not less. 4. The customary and SI transmitted load formulas give pounds versus kilonewtons. Don't mix a customary number into the metric form. 5. The form factor is dimensionless, and the radial force is fixed by the pressure angle. Quick recall. Pitch line velocity is pi times diameter times speed over 12, diameter in inches. The transmitted load is 33,000 times horsepower over velocity in customary units, or the 60,000 form in metric. The radial load is the tangential times the tangent of the pressure angle, and the resultant is the tangential over the cosine. The Lewis stress is transmitted load times diametral pitch over face width times form factor. Golden rule: velocity in inches, load from power, split by the angle, and only the tangential load goes into the stress. Next up, Lesson 6. Helical, bevel, and worm gears. Spur teeth load in a single plane. One tangential force, one radial. Angle or turn the teeth, and a third force appears, an axial thrust. Lesson 6 builds the helix and cone angles that create that thrust, and the worm drive where a big speed reduction comes at the cost of efficiency. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.